Okay, kids, you're going to get the short version of everything today because we've only got a half hour. You're going to learn about increasing and decreasing functions, and essentially you're going to learn if a function's increasing, the first derivative is positive, and if the function's decreasing, the first derivative is negative. Then we're going to learn the first derivative test to determine if a critical point is a min, max, or neither. Up till now, we've pretty much been looking at graphs or using our cleverness, but now we'll use the first derivative test to determine, hey, if a function goes from increasing to decreasing, that must be a relative maximum there. And if the function is going from decreasing to increasing, you must have a relative minimum there. You see what I mean? That's what the first derivative test is, and that's what that note sheet I gave you is going to be about. And then finally, we'll talk about relative mins and maxes at endpoints, which is just looking at the first derivative test again, only for one side, because there's nothing on the other side of the endpoint. Well, here we go, increasing and decreasing functions. Increasing and decreasing functions. Okay. One, f increases on an interval if x1 being less than x2 implies f of x1 being less than f of x2. That's what it means for a function to be increasing. If x2 is bigger than x1, then f of x2 is bigger than f of x1. And that's going to be true for all points in that interval. That means your function, if this is x1 and this is, well, I mean, it doesn't have to be x1 and x2. If this is a and this is b, and I've got a function that's increasing on this interval, it just means if I've got an x value that's bigger than another x value, then the f of x is going to be bigger than the other f of x. That's simple. And then f decreases on an interval if x1 being less than x2 implies f of x1 being greater than f of x2. That means if your x is to the left, if one x is to the left of another x, then the y is going to be bigger for this guy than for that guy. That means my function is decreasing. So imagine I have a function that's going like this, where here's A, here's B, here's C, here's D, and here's E. Okay? I've got a function going like that. All I want you to see visually is when my function is increasing, the slope of my tangent at every point on that interval is going to be a positive slope, right? My function's increasing from A to B, and look, every tangent I could possibly draw on that interval has a positive slope.
Hey, Mr. Shana?
What?
Why is it x1 and less than x2 for the second one? Shouldn't it be greater than?
No. No, if one x lies to the left of the other x, then its y value will be greater than the other guy's y value. That's what I'm saying. That's if my function is decreasing, if from A to B, and let's say this is my function, is decreasing, then if I had two random x's, x1 and x2, and x1 lies to the left of x2, x1 is less than x2, then f of x1 is going to be greater than f of x2 because it's decreasing.
What about that? What about the same thing? How do we split it?
Well, the other one says if x1 lies to the left of x2, then f of x1 is gonna be less than that. You're confusing me now. Then f of x1 is gonna be less than f of x2. Like, if this is x1 and this is x2, then this is f of x1, and this is f of x2. You see? And f of x1 is less than f of x2. If my function's increasing, the y value for this guy is going to be less than the y value for this guy. But if the function's decreasing, the y value for this guy is going to be greater than the y value for that guy. Yes?
I think you only have 2 minutes left of core time.
How can that, okay. Wait, how can that be?
Did you clear out?
I thought I cleared out the Monday, Tuesday, Wednesday things.
Because it says you only have 2 minutes left.
Let me look at, you did super fast.
And then there's also that little flashing thing.
Okay. Oh, yeah, that's telling me that I'm almost out. Okay, here, let's boop.